Right, we're going to talk about odd and even functions. First, we need to settle something. If you have a number, well, let's stop there. Let's not start there. If you have x to the 7 over x to the 5th, remember x to the 7th means to multiply x by itself 7 times, and x to the 5th means to multiply x by itself 5 times, and x over x is 1, and x over x is 1. In fact, this is going to happen 5 times. And when you multiply all the ones, you get 1 times x is x squared. In fact, if you subtract the exponents, you will get the answer. Okay, having said that, let's consider x to the 9 over x to the 9. Well, this is equal to 1 because the numerator and denominator are the same, on one hand. On the other hand, you subtract the exponents and you get 0. X to the 0 is 1. Whether you have 9 or 19. The exponent was 19 instead. 19 minus 19 is still 0. And x to the 19 over x to the 19 is still 1. So, regardless of what the exponent is, if they're both the same, you get x to the 0, which is 1. And you don't even want the middle step. X to the 0 is 1. Okay, so why all this? Well, let's see right now. If you have a constant and somebody asks you, oh, what's the power of x? Well, 7 is, of course, 7 times 1. 7 is 7, and 1 is x to the 0. That is, if you have a constant and somebody says, what's the power of x on that constant? You say 0, the power of x is 0. Okay, if you have a constant, negative 32, this is negative 32x to the 0. What's the power of x? 0. What's the power of x here? 6. If you don't see an x, the power is 0. Because you can always take negative 32 and think of it as negative 32 times 1. But this is just another way of writing 1. X to the 0 is 1. Okay, so now let's define an even function. Even function. If you have a function and you plug in negative x, and it's the same as if you plugged in x. That is, plugging in 5 is the same as plugging in negative 5. You get the same answer. Whether you plug in negative 34 or positive 34, you get the same answer. That's an even function. An odd function is if you take a function and you plug in negative x. Well, you get back the same answer, but with a minus sign in front. In other words, if f of negative 5 was 15, then f of 5 will be negative 15. They differ by a sign. So, if I tell you that f of 7 is 24, well then f of negative 7 will be negative 24. If I tell you f of 8 is negative 2, well if you plug in negative 8, you get back the same answer with a sign change, with a minus sign in front of it. You get back the same answer with a minus sign in front of it. But you put a minus sign in front of a number, it changes the sign. Okay. Now, there are many functions which are not polynomials, which are odd and even. For example, the cosine of negative x is the cosine of x. Doesn't matter whether you plug in x or negative x to get the same answer. So for example, if you have your calculator and you want to find the cosine of negative 60 degrees, you don't even have to type in the negative sign. You don't even have to type it in. It's an even function. Sine, on the other hand, is an odd function. The sine of the negative angle is the same as the sine of the positive angle, so minus sign in front. For example, the sine of negative 70 degrees is negative the sine of 70 degrees. It's an odd function. Now, when it comes to polynomials, it's very easy to tell if it's an odd or an even function. When it comes to polynomials, it's very easy to tell if it's an odd or an even function. If all the powers of x are even, then it's an even function. If all the powers of x are odd, then it's an odd function. If you have odd and even, then it's neither. So if you have 7x cubed, well, let's make that 5. 7x to the 5th minus 3x cubed plus 13x minus 11. Remember, the power here is understood to be 1. A lot of people would say, ooh, this is an odd function because all the powers of x are odd. No, they're not. No, they're not. There's a power which is not odd, 0. This function is neither odd nor even. F is either odd nor even because it doesn't have all even functions, nor does it have all odd functions. You need to be mathematically mature enough when you see a constant 11, you think exponent of x is 0. Now, you have f of x is equal to 3x to the 6th minus 21x squared plus 13. This is even because all the powers of x are even. And it's not because what I just boxed are all even numbers, but when I add in the missing one, the understood one, that is x to the 0, 0 is even. 0 is even. If you have g of x is equal to 7x to the 5th minus 3x to the 7th plus 13x, this is odd because all the exponents of x are odd, including that understood one. Okay, you need to be careful with the constants. You need to be careful with the constants. If all the exponents of x are even, then it's an even function. If all the exponents are odd, then it's an odd function. Well, what if you have a rational function? A rational function is one polynomial divided by another polynomial. Okay, you can't just look at all the exponents and say, oh, they're all odd, so it's odd. And what happens if you plug in negative x. You get 3 times negative x cubed minus 4 times negative x over 7 times negative x to the 5th minus 3 times negative x. Well, negative x cubed is negative x cubed. Negative x cubed is negative x cubed. And if you multiply by 3, you get negative 3x cubed. Negative 4 times negative x is positive 4x. On the bottom, negative x to the 5th is negative x to the 5th times 7. Negative 3 times negative x is positive 3x. Well, when I look at my result, it doesn't look like g of x. It doesn't even look like negative g of x. But I can factor out a minus in the numerator. This gives me 3x cubed minus 4x. When you factor out a minus, all the sign changes. This became positive. There's no sign in front of the 3. It's positive. And the positive 4x becomes negative 4x. When you factor out a negative from the bottom, each of these signs changes. That is what I put inside the brackets. All the signs change. Instead of negative 7x to the 5th, I write positive 7x to the 5th. And I don't even have to write the positive sign. Plus 3x becomes minus 3x. Now, negative over negative is positive. It cancels. So we get 3x to the 3 minus 4x over 7x to the 5th minus 3x. That's g of x. This here is g of x. How do I know that? Because I just read it. It's the same thing. It's g of x. That is g of negative x really equals g of x. It's an even function. Basically, if the numerator is odd and the denominator is odd, well, odd divided by odd, think negative over negative. That's positive or even. Okay, odd divided by odd is even. Think of odd as negative and think of even as positive, and then you'll have the answers. You have an odd function divided by an odd function. Think of odd as negative. Negative over negative is positive, which is even. That is, odd divided by odd is even. If you have an even function and you divide it by an odd function, even is positive, odd is negative. Positive over negative is negative. Negative is odd. If you have an odd function divided by an even function, in case of polynomials, if the top one has all odd exponents and the bottom one has all even exponents, you have an odd over an even. Think of odd as negative. Think of even as positive. When you divide and the signs are different, you get negative, which is odd. If you have an even divided by an even is positive, even is positive. Positive over positive is positive. Positive is even. So you don't even have to go through plugging in negative x and see what you get. Memorize this table. So for example, if you have sine x over cosine x, we talked about how sine x was odd, and we talked about how cosine x is even. Negative over positive is negative. So it's an odd function. This is an odd function. That is, if I told you that f of x is equal to sine x over cosine x, then f of negative x will be negative sine x over cosine x. It'll be negative f of x. And this is good to know because, for example, if I tell you f is odd, or let's say f is even, and you need to know what f of 17 is and what f of negative 17 is. If it's even, you can do it in half the time. If f of 17 is 13, then f of negative 17 comes for free. It's 13. If I tell you it's an odd function, then you get back negative 13. Now, the next thing is how can we use knowing that a function is odd or even to graphing it? Well, suppose you know a function is even. That is, if you plug in 7 or negative 7, you get back the same value. In other words, in this function, if 7 you got back that negative value, negative 9. Well, when you plug in negative 7, you also get back negative 9. In fact, if the left side, the right side, of the y-axis looks like what I just drew, well then the left side is going to look the same. So maybe you spent some time figuring out the graph looks like this, but then the left side comes for free because we know it's even. Okay, we know it's even. For this x value, you go up that amount. For that same negative x value, you go up the same amount. That is, the y values are going to be the same. They're mirror images across the y-axis. If you come to know that some function goes like that and it's even, well then the other side of the y-axis comes for free. It's the mirror image. There it is. You get stuff for free. If you know what one part of the graph looks like, then you can find out what the other side of the y-axis looks like. That's what an even function does. It reflects across the y-axis. They're mirror images. Now, what does an odd function do? Now, I'm telling you the graph is odd. Well, for this x value for 3, you get back negative 9. But f for 3 is negative 9. If you plug in not 3, but negative 3, you get back negative f of 3. That is, you get back negative 9. You just have a sign change. That's what I'm saying. If you plug in 3 and you get that number, if you plug in negative 3, you get negative that number. You get back 9. So when I plug in negative 3, I get back 9. Instead of going down that amount, I go up that amount. If over here, for this x value, we're up here. If this is, I don't know, 7, negative 7 is probably right here. Instead of going up that amount, you go down the same amount. So, if the graph looks like this, what you get is 2 reflections. You get 2 reflections. You get a reflection across the y-axis and the x-axis. Which you do first is up to you. You can reflect across the x first and then the y. Let's reflect across the y-axis. that is going to give us this. And then we reflect what I just drew in the dashed line, we reflect that across the x-axis. And then we get what we're supposed to get. There it is. Okay, that's an odd function. It's a reflection across both the x and the y. Okay, you can also think of it as a reflection across the line y equal x as well. That might be more complicated. But basically, if you put red paint along here, and then you folded the paper or the whiteboard across the line y equal x, you will then get red paint along here. That's exactly what happens with odd functions. Let's look at one more. So again, if you notice the function is is odd, all you have to do is say graph the portion, or find points where x is bigger than 0, and then the left half comes for free. If you have a graph that does that, and I tell you it's odd, notice I only plotted x is 0 and more. I didn't plot where x is less than or equal to 0. So how do we find out what it should look like? Well, since it's odd, it's the reflection across both the x and the y-axis. Let me go across the y-axis first. That is going to give me a graph that looks like that. Now I reflect this across the x-axis, and I get this. Okay, so this piece here, along with this piece here, that's the graph of the odd function. Okay, that's the graph of the odd function. Okay, that finishes up odd and even functions. Next video is going to go back to more on transformations.